Hello, EFR 516 students. Today we're going to go over online exercise '06, example one-way ANOVA. So we have 5 problems in this assignment. So the first one says, conduct an independent samples t-test with dependent variable 1 as the dependent variable and independent variable 1 as the independent variable. Is there a difference, non-directional, in these two population means? Write up results in APA, include the main SPS output table. So to do this assignment, we're going to need our data set, and the data set is example data save. So EFR 516 online EX05 example data. So this is the data set you're going to use for the assignment. And here's our first two variables over here. So we're going to do an independent samples t-test with DV1 and IV1. So we'll go ahead and do that. We're going to go analyze, general linear, or compare means, independent sample t-test. So analyze, compare means, independent samples t-test. We'll go ahead and click on that. We'll clear what's in our analysis. So we're going to put the dependent variable under the test variable and the independent variable under the grouping variable. Now we see our groups are 1 and 2, so we're going to click define groups. Now if you can't get that, you're going to click in this space in here where the IV question mark. You can click in there and then define groups. Now our groups are 1 and 2. They don't have to be. They could be any number or even script. So put 1 and 2 in there. I'll say continue, and I'll go ahead and say OK. So this gives us our output here with our means and our one-way ANOVA table. So I've already brought this over into the assignment. So here's our ANOVA table. So if we looked at the means in the output, I'll go ahead and bring those means over as well. Paste them in there. So as we see in the means, they're 7.6 and they're 6.9. Now, we always expect there to be a difference in the sample. Our question, do we think this difference, this observed difference, is due to chance or not? Okay, so I'd actually brought in the DV5 means. Now I have the correct means over here. So as we can see the difference in the means, so the actual mean difference is shown down here as minus 4.252. So we want to look at our analysis, and we're going to go ahead equal variance assumed, even though the sig's less than 0.05. So I'd like you to use this first column here for consistency. So if we looked at our sig on this one, it's actually a 0.05. That's interesting. So it's a t-test. It's a t with kind of degrees of freedom, 18 degrees of freedom. Its value of our t is minus 2.101, comma, and is p less than or greater than 0.05. Now it's actually 0.05, right? So it's not less than 0.05. So I'm going to say p greater than 0.05. Now, I might carry it out a little farther because this is right on the line, questionable, but we'll just go with the greater than 0.05 right now. Again, I might carry it out a little farther or rerun the analysis and add a sample or two, but that's right on the line. You almost never see that. Okay, so there's our APA for this t-test. And that's what I'm looking for in the first case. Okay, so now come down to number 2. and it says conduct a one-way ANOVA on the same data set as the dependent variable. So we're going to use the same data as we did before, but now we're going to conduct a one-way ANOVA for that. So when I run that, I'm going to come over here to Analyze. I'm keeping my same data set. I'm going to go Analyze, General Linear Model, Univariate. My fixed factor is, I'll reset this. So my dependent variable, dv1, and my independent variable is my fixed factor, right? So I've got both those, and I'll go ahead and say OK. Now that's going to give me the ANOVA table right here, and I'm going to pull that ANOVA table over and into my assignment. Okay, so here's our ANOVA table, and I'm asking you to write the APA for it. So go ahead and write this APA. It's an F. I know this, here's my F column, so we see the F, and an F has a numerator and denominator degrees of freedom. So here's my independent variable. I'm using that row right there. Okay, so it has 1, comma, 18 degrees of freedom. The air, notice the air is 18 degrees of freedom. Its value is equal to 4.414, 4.414, comma, and again, I'm going to say P greater than 0.05. Okay, it's actually 0.05, but it's not less than. And that's our criteria for shifting it. Now I have a couple other questions here because the t-test is a special case of the ANOVA analysis where you have two groups. And what we're going to notice here is our, we'll come up here and our p-value was 0.05. So sig two-tailed. So for the two-tailed test, it was 0.05. And for the ANOVA test, it was also 0.05, as we see right here, 0.05. So we see that we got the same result as far as p-value. Now, the t that we got up here was minus 2.010. So I'll go ahead and put this here. 2.010, 2.10101. Now, and because we're dealing with the F, the F's always going to be positive, so we're going to ignore the negative sign. And now, if we square the t, we should get our F value. If we take the square root of the F value, we should give our t. So I'm going to go ahead and use a calculator for this. And you'll have to use a calculator or use your phone or something. So if I take 2.101 and I square it, I get 4.414. And as we note down here, here's our F, 4.414 exactly. So a t-test is a special case of ANOVA when you have two groups, and you're going to get the same results on either case. And that's what I'm looking for, the APA and these two confirmations. And like we had done in class the other day, I'm going to go ahead and make these yellow. So I'll put my answers in yellow. I'd appreciate it if you do that for me. Okay, so now we're down to number 3. It says conduct a one-way ANOVA with dependent variable 3 as a dependent variable. Is there evidence that the population means for the groups are different? Write up your results. So this is just a straight one-way ANOVA. Now we have 4 groups in this analysis. So if you think about H naught, it's that all these group means are equal. And In fact, you could add one more equal to an overall mu. So is the first group equal to the second group is equal to the third group, meaning is there some population value here for these? Just want the mu. Is it equals some overall mu? And alternatively, it's not so, meaning any two groups that are different could kick the allow us to reject the null and accept the alternative hypotheses. So I'm going to work with dependent variable 3. So I'm going to go to my SPSS. I'm going to find dependent variable 3. Come up here, analyze, general linear model, univariate. Go ahead, reset this. I'm on number 3. Dependent variable is going to go dependent variable. Independent variable 3, go in there. Okay, that's all I'm looking for right now. I'll say OK. Here's my ANOVA table. I'm going to go ahead and bring that in. Paste it right here. So I'll write my ANOVA. My ANOVA is an F with okay, my independent variable. So I had 4 groups. So I got my degrees of freedom are 3, and my error is 16. Okay, that equals, what's the value of my F here? I'm on my independent variable line. It's 6.473, 6.473, comma, P what? P is less than 0.05. And I'll go ahead and highlight that. So that's all I'm looking for there. Reject the test, the omnibus test of the null hypothesis, and we think there's something different in the groups here. So I'll go to number 4. Okay, it says conduct a one-way ANOVA, just like we did, but then we're going to follow it up with pairwise Tukey. So under post hoc test, we're going to follow it up with the Tukey, which is a pairwise comparison. So we're going to look at all the pairwise comparisons here. Like for example, our question is, which one is different if we reject the null hypothesis? So let's go ahead and do the analysis. So go to my SPSS, go to analyze, general linear model, univariate, just like we did before. I'm going to reset this. I'm going to bring over number 4, dependent variable, number 4, independent variable, fixed factors, and now we're going to post hoc tests. I'm going to select Tukey, and that's going to be all here. I guess I first have to bump over the independent variable, and that has my different groups, and that's giving me the options to do Tukey. Now my sample sizes aren't perfectly the same size, but close enough here. So I'm going to click on Tukey, and that's going to do all the pairwise comparisons. So as I continue, and then OK. So the first thing I want to bring over is my ANOVA test, and I'll bring that over. Paste it right in the assignment here. And so I'm going to write my APA, which is an F. It's 3, we have 4 groups, and 16 degrees of freedom. I get the 16 from the error row. I got the 3 from my row here for the independent variables equals, so I'm on this independent variable, it's equal to 0.311, comma, and then the P is greater than 0.05, because we see our p-value is 0.817. So we failed the omnibus test here. Now normally if I failed the omnibus test, I wouldn't even go look at my comparisons because I'm finding no evidence of rejecting the null of the means being all the same. A failure to reject the null, meaning I'm not rejecting the null. But if I go get my Tukeys, and I'll bring those over, And what we're going to see, so I'm bringing these over. Now, one thing that we're interested in is all the pairwise comparisons. Well, there's only 6, so the SPSS is giving us like um, it's giving us more tests than we actually have. Okay, so um, uh, we have 6 comparisons, and these are the comparisons I'm interested in: 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. And I can come here and I look at my sig values. These are my sigs in this column right here. Now, SPSS, what it did, it's going to hold the family-wise type 1 error rate at 0.05. So it's adjusted up each one of these p-values to control that type 1 error rate. So we're looking for here is any of our comparisons less than 0.05, and we see none are, right? So our basic answer is none, right? I'm just going to go ahead and write none. Now, if there were some, I'd say 1 versus 2 sig, and I'd do an APA statement for that. P whatever, P less than 0.05 for any of these given values. So this is none, and here's my APA. Okay, so now I'm going to go to the last problem here, number 5, and again we're conducting a one-way ANOVA, and we'll put the APA, but then we're going to follow it up with some contrasts. And we're going to actually do these by hand, these contrasts, because we could do simple or complex contrasts, and we need to learn how to do these and where the math comes from. So let's go ahead and do an ANOVA with DV5 and IV5 to get started. So I'm just going to come up, I'm going to go Analyze, General Linear Models, Univariate. I'm going to reset this. Independent variable is 5, dependent variable. And I'll say, let's see, I want to ask for my means as well. So I'm going to go Options, and I'm going to go click on the independent variable, and I'm going to bump over. And what that's going to give me is my means. I need that. So I went to Options, and whatever I want to bump over, I don't care about the overall mean, but I care about the means for my groups. I'm going to bump those over, and I'm going to say Continue, and then I'm going to go ahead and say OK. Okay, so here's my ANOVA table, and here's my means table, and here's my numbers in my individual cells. So go ahead and bring those over into the assignment. So here's my ANOVA, and from that, I can see that I have an F, and it has 3 and 16 degrees of freedom, so just like before, my overall ANOVA, which is an F with 3, 16 degrees of freedom. It equals, what's the value of the F? My F equals 2.006, 2.006, comma, P what? P greater than. My actual P value, again, ANOVA is non-directional, so my actual P value here is 0.154, so my P is greater than 0.05. Now that's my APA. So then I then conduct 2 contrasts. One where you compare groups 1 versus 2, and the other where you compare groups 1 and the average of 2 and 3. Okay, so the first contrast, here's my assignment. So the first contrast is we're going to deal with this. We have psi hat is our contrast, and then we have weights. So, and what under the null, we believe that psi is equal to 0, and or under the alternative, psi is not equal to 0. So psi is the product here of our weights and our means for our cells. Now, there's an example here with actually 4. Now, you could do more than 4. So this is a psi, and it's the weights. And now our weights have to sum to 0. When we sum up all our weights, they have to sum to 0. So, and then the standard error for psi hat is the mean squared within times the weights squared divided by the size of the sample in that group. And then the test statistic is psi hat over standard error psi hat. And then we calculate a p from that. We'll go to Excel for that and from there. So let's go ahead and look at this first example. It's right here. So again, you'll have to calculate this out by hand, but we're going to look at contrast between 1 versus 2, group 1 versus 2 from the independent variable 5. So our weights are just going to be 1 and minus 1. Now, do they sum to 0? Yes, they do. Our weights sum to 0. And this is just our standard t-test of group 1 and 2. So our weights here are 0, so these numbers don't come into play. So psi hat equals 7.62 minus 6.13. Okay, and we're going to go ahead and look at our mean differences. I'm going to go find them here. Here are our mean. So 7.62 and 6.913. We get those from the means table for group 1 and group 2 right up here. So the standard error is equal to the mean squared error, right, times the weight squared divided by the sample size for that group. Well, where do we get the mean squared error? We get it from our ANOVA table. So mean squared and error, where do they intersect? That's our mean squared error. That's the variance of the errors, or it's a pooled standard deviation once we take the square root. So then our sample sizes are here. So we're going to go ahead and fill that calculation out. So here's the mean squared error, and here's our weights. And notice the other ones are 0, so they just go away. So our standard error is 2.534. When we take the product of that, or the division of that, we end up with 0.2784. Now, to get the actual p-value, we can just go in Excel, and here's the function for that. So you go into Excel and you put an equal sign and put this function, then you put your test statistic and your degrees of freedom in there. And you're going to end up with a two-tailed p-value. And so our p-value is 0.784. Well, is that greater than or less than 0.05? So we can write this up. It's a t-test. It has 16 degrees of freedom. Where do we had 16 degrees of freedom. Where do we get that? We get that from our error degrees of freedom table, because we're basing it off our standard error estimate of the ANOVA table. And the value, 2.278, p greater than 0.05. So that's the answer to this contrast. Now, we did this based off the ANOVA. What if we just said, okay, well, I'm just going to go in and do a t-test with these two groups. Now, I went ahead and did that, and here's our results from our t-test. Okay, and we'll see that our results from the ANOVA here, I'm going to highlight it in yellow, are similar to the t-test. Okay, we both p was greater than 0.05. The test statistics are a little different. Well, why is that? Because the ANOVA used the estimates from the overall experiment, meaning the entire ANOVA, where the t-test only used them for those groups. Okay, so that's why they're a little different, where you're getting your estimations from. But you can see the results were basically the same. The conclusions were the same. Okay, so now I want you to go ahead and do this, and now we look at the next one. Okay, so the next one, we're going to take a contrast for 1 versus the average of 2 and 3. Okay, so we're going to say, hey, what if like group 1 was a control and groups 2 and 3 were some form of drug condition? If I want to know, was there a difference from the control versus the drug condition? Well, so I need to set my weights. Now my weights need to sum to 0. So now one way I can do that, now the book uses some larger numbers, you can use those as well. But we're going to go ahead and use these fractions for our weights. So we're going to use 1/2, and our two weights are -1/2 and -1/2, and then 0 because we're not using group 4. Now we go ahead and do the math there, and as you can see, right, we end up with a t-test down here, 16 degrees of freedom, its value 0.324, and p greater than 0.05. Now, to help you out with these calculations, I've actually created a little spreadsheet. Now, it's not perfect. You could create your own just to do all these calculations. And so here it is. It's called EFR 516 ICEX05 contrast calculations. And here's the first example. And here's where you can put in your results here, put in your observations. So as you see, the orange here is coming from the ANOVA table. That was the mean squared error, and then the degrees of freedom. So I got those from the ANOVA table. The weights, you have to come up with those. Okay, so in the first case, my weights were 1 and -1. They're divided by 1 here. Okay, over here, there were 1/2, 1/4, -1/4, -1/4, and 0. So the weights there are just coming out here, and because it's 0, this will work out as 0. This last one as well. So these were my weights here, and there's a little weight check. So there's a weight check here. Here are the weights, and you put them in here: 1/2, -1/4, -1/4, and 0. And here they sum, and if that's equal to 0, then you're okay with your weights. And here is the sample size right there. You need your sample size for your groups, and then it'll do all the calculations for you. As you can see here, here's where we're getting our p-value from Excel. And if you're not familiar with equations, it's well worthwhile learning how to do equations in Excel. You put the equal sign first, and then you put in your equation. So here is the example for the first one. So when you go ahead and do yours for the assignment, you can use this if you'd like. Okay, that's all I'm asking for this assignment. Good luck with this. Will you be using contrast in future assignments as well? Thank you.